Assalamu alaikum wa rahmatullah. This is for lecture 8, where we will have the second part, the third part actually, the last part of our electrostatic field. So here we will learn about mostly the material space and the current, the behavior of the current in a medium. So far in our all the lectures we have actually learned that all the charges are static, and this static charge are in free space, means we consider that there are no material and there is no material space around it. But basically that only can happen when it's out of the space, means in the the free space of the universe. However, when we are on Earth or any other planet, this scenario is not possible. So the more realistically we talk about, then the electrostatic charge will be for sure considering within the material space. So without further delay, we go back to our contents. So we need to know about the material space first, that what is actually what happens actually in the material when the electric field is applied. So basically we can classify all the materials based on its conductivity. The conductivity is basically the ability of any material to conduct the current. Now, what is current is basically the movement of the charge. It can be either positive charge or negative charge. However, the positive and negative, they are actually complementary, because you will find the positive charge where you will find the negative charge there also, because they will try to pursue each other. Now, if you put too much positive charge, then other positive charge will repel back, but most of the negative charge will be attracted towards this positive charge. So it means if you think about charge, means either it can be positive or it can be negative, because they are self-complementary. So, and one more thing is the conductivity unit is basically the Siemens per meter, or the inverse ohm per meter. Exactly opposite of the conductivity is, we call the resistivity, means how much the material can resist the current, means how much a material will not allow the current to pass. So they are totally different. So conductivity allows the current. Conductivity is an amount that tells that how much current will be allowed through the medium or a material, and at the opposite side, the resistivity is basically is related to how much it will resist the current, means how much it will not allow the current to pass through the material. However, basically the secret behind the conductivity of any kind of material, whether it's metal, what is liquid or gas or solid or whatever you talk about, it's actually lie beneath the bonds of the chemistry, or the electronic bond, we call it, of the electrons, protons and neutrons, basically the electrons we call it. So there are many layers of electrons which are circling around the nucleus that we know from our chemistry. So in that different orbits we have different number of electrons, but to produce a conductive material or to determine the conductivity of any material, basically the valence electrons, they actually determines how much conductive the material. It means in one bond it can be a hybrid bond or it can be a normal bond. There are different kind of bonds actually, but I'm not gonna go deep inside that one. So basically valence electron means the electrons which are at the outer orbit of any atom. So as many as electrons as it have, as much as it can give you the conductivity. Means whenever an external electric force applied to this atom, it actually tends to change the movement of these electrons. Means it makes them free from the attraction of the nucleus of this atom, which can be moving freely. So by that moving freely, the more it conducts the current, because when you can free one electron or multiple electrons, they tends to run, they tends to actually, I would not say run, they tends to move through any material freely. When it moves, then it conducts the current. So by that definition actually, that more strong bond with the nucleus, the electrons which have more strong bond with the nucleus will have less conductivity. However, the electrons which have less this strong bonded with the nucleus will have higher conductivity. So we move on to our next slides, that basically based on this conductivity we can classify any material into three different, basically two, but we consider three actually, three different criteria of materials. Number one is insulator. Means the insulator means the materials which doesn't allow current to pass through freely through the material. So the insulating material will resist the current, means it will not allow the current to pass. A perfect insulator basically will not have any conduction current. Okay, later on we will discuss about this conduction current. So there is another which is called conductors, means totally opposite of the insulator, means the conductor material which will allow as much as current that it can. On the contrast of the insulator which blocks the current, the conductors are actually allows the current as much as they can. There is one material in between. They are neither insulator nor conductor, which is called semiconductor. So actually in the like modern physics and something we talked about a lot about the semiconductor and something. The whole electronic industry is basically based on these semiconductors. However, basically we will not go deep inside what is inside these materials, but based on the current principles, we will try to characterize those different material spaces. Now let's go and check that when we apply an electric field, what happens to the material space. When you apply any electric field to any material space, what it happens, let's say this positive here and the negative here. So the positive charge will tend to go towards the negative, right? And the negative will go towards the positive. So there is an a relative movement between the charges, right? So due to this relative movement of the charges, the current will start flowing, and it will oppositely flow of the direction of the electron. Means if electron goes to the left, and the current will flow to the right, because the positive charges are flowing towards the right side. So the current flows like this and starts the flowing of the current. It can have a equation such as like this: I will be I plus and I minus with this direction. We know about these directions already. So this is as simple as that actually, but there are some description I have given here. You can read about it, and then the current, what is actually it's a rate of the charge that it passes through any cross section, which is we call it ampere. So ampere is equal to coulomb divided by second, means time actually. Coulomb by time means Q divided by T. These all things we know from our physics already. Now we move on to see that there are how many types of currents. Basically there are three types of current, because we know that there are three different materials, right? So in three different materials there are three different current which flows. The three different have different way of conducting current. That's why their names are different. One is, we call it conduction current, which is the current flow in the conductor. The behavior of any current flow in any conductor, we call it conduction current. Then there is through an insulator there are actually one type of current, which is, we call it convection current. It still flows through, but not as high and as dense as the conduction current. So there is no conduction current here, but there are convection current. Later on we will see how. I will not go so deep actually. Basically we will talk about this one more than others, but I will touch these two also. The third one is the current in a semiconductor, which is we call it displacement current. So due to the current which is non-contact current, we call it a displacement in the field actually creates the current. That's why we call it displacement current, which is a AC current in a capacitor. So the current in a copper wire is the conduction current. Electron beam, which produce actually the cathode ray tube, it produces actually a lot of high frequency beams, and produces a lot of electrons also, which is convection current, and then the displacement current. So mostly we will talk about this one. We will touch this one in the beginning, then we go to our conduction current. However, regardless of whatever current we have, the current density is ampere per meter square, which is actually J, means actually delta of I means the what do you call it? Basically delta means the differential current divided by the differential surface, means ampere by meter square. So no matter what happens, I can be calculated from the current density, which is double integration due to the with respect to the surface of that current flow. So there are some description here I have given, but no need to go through this description if you don't want, but for your understanding I would recommend you to go through. So if we integrate this one, then we get I is equal to Jn by A, which is J is the density of the current and A is the cross section of or the surface of any material. So by multiplying these two we get I. So these principles are actually same for all three materials. So now we go to the convection current. So a convection current is defined by a charged particle through any insulating medium. When you charge any particles in any insulating medium, they will tend to produce a current which is actually defined by the drift velocity of that medium, which is very low actually, which is very low. The current is the velocity of those currents are very low actually. So if we have a rho v, means a volume charge density, and we know about the drift velocity of any insulating material, then we can get our convection current. How we can get it? We can get it by multiplying this one. So rho v multiplied by u. U is the drift velocity of the medium, insulating medium. So the J means the total current density is equal to the charge density multiplied by the drift velocity. So this is how the current density is calculated. Now if you know the current density, from here you can obviously find out the amount of current, means the amount of I, because we know this I is equal to JA. Okay, so that's how you can calculate. Now as I told you that I will not touch that much this convection and displacement current. So let's go to the displacement current. Here is mostly the same. So let's talk about a capacitor, that if you apply a voltage here, let's say this negative to positive voltage here, so all the positive charge will tends to accumulate here, right? And in opposite manner, all the negative charge will be accumulated here. But there is one thing that we learned, that all the positive charge produces an electric flux density which will go through any medium, and it will end up to a negative charge, right? Now due to this displacement, what happens in the accumulation of high positive and negative charge, you will feel a current flowing through here. This is called the displacement current, which only occurs in the semiconducting materials, which is also we call it the dielectric material sometimes, because we need a dielectric medium here to increase the electric field between these two capacitor plates. Here these things you know already, but I just put it there for your convenience. Now we go to conduction current. Here in the conduction current, basically the free electrons, how the free electrons moves when a voltage, means an electric field is applied. Let's say we applied a positive and negative field. So this due to the attraction of the positive, all the electrons will tend to go through this, right? But the current will go through opposite side of the movement of the electron. So based on this surface area, actually A cross section, the current can be measured. So the length, we need the length, we need the area, and then there is one term it calls the conductivity, sigma. So these things are actually needed to be calculated. So now we go to how you can measure the conduction current is mostly the same, but a little different. So from the drift velocity, we know from the insulating material that J is equal to rho v u. U is the drift velocity, right? But U actually defines by the conductor mobility also. Means if we apply an electric field and then it have a conductor mobility, where the conductor mobility is very low for insulator, means it's very negligible. This one is very negligible, so they don't use it. But here the conductor mobility is very high, so that's why you need to replace with conductor mobility and multiply with E to replace with the drift velocity. So once we replace this one, we get our final result. However, these things, they comes from somewhere, but as I told you that derivation we will not do too much in this course. Okay, so but there are some definitions here I put. You can learn about it, you read about it, and if you have confusion you can discuss about it with me. So now this we will put it here, and then finally we get J is equal to rho V mu E, which is sigma. So this whole part, this part actually sigma means the conductivity. So if you apply the conduction mobility with the charge density, you got the conductivity of any material. Here the voltage has been, there are some we call it the applied voltage law, where if you apply an electric field and if you know the length of the material, like this here, the length of the material, if you apply an electric field, then the voltage is as simple as that, V is equal to E multiplied by L. So that's how you can calculate what is the electric field of the conducting material. In similar way, J, we know that J is equal to I by A, right, and is equal to sigma E. So this equation also can be used to find L, V, or sigma, and so on and so forth, and we know V is equal to IR. At the end, we can find the resistivity of the wire by dividing sigma and the cross section of anywhere with its length. So these things you need to remember, because possibly in the exam any question comes from here, the formulas will not be given. So here you check the current density, actually not current density, the power density actually calculated from this actually. The P is equal to E dot J, which is sigma E square, so which is actually equal to V square by R. We are actually very close to our lecture today. We don't have that high today, contents are not so much. So here we do one example and then it will be finished. However, I will post one problem in the assignment, as an assignment later on, that you can later on for the attendance. I will post it. It's not included in the lecture, but I will post it separately. So here the example is saying that a copper wire sigma is given of a copper wire of this, means conductivity of 5.8 multiplied by 10 to the power 7 minus 7 actually. But however, remember this one, the copper wire usually it's not minus 7, it's 7. But however, whatever is given in the exam or in the question, in the quiz, you need to follow. So a copper wire which have a conductivity of 5.8 into 10 to the power minus 7 Siemens per meter, or mho, they call it mho per meter, and they have a charge density of minus 1.4 into 10 to the power 10 coulomb per meter square, and have a radius of 1 mm, and the length is given. So carries a current of 1 m is I is given. Assuming the uniform current density, determine the wire resistance, the current density, the electric field within the wire, and the drift velocity of the electrons in the wire. So having no more further delay, we go to our solutions. So let's see here. R, as we derived all the equations already, R is equal to L sigma by R is equal to L divided by sigma A. So we know all the values. It's supposed to be, I think this there is a mistake possibly. You use this one, okay, minus 7, okay, not this one, 7. So once you check minus 7, and then maybe different value will come here, but the procedure is the same. So A, how we will find of a circle is pi r square, right? So R is given, which is radius is 1 mm, means 0.001 square, multiplied by the given conductivity, and then the L is given as 20 centimeter, which is, you need to convert it into meters. So remember, all the units have to be SI units, means everything is in, if you do it in meter, it have to be all in meters. Similarly, when you find the current density, means J is equal to I divided by A, which is this, and you know it already. And the last the C is E is equal to J by sigma. Again, you use this one minus 7 here, okay, you use minus 7 here, not 7, okay. So you get this value, maybe a different, maybe mega, you will get it instead of milli. Here you will get mega, possibly mega ohm, I believe, and here also you will get mega, I'm not sure, okay, just check it, okay. And now the drift velocity, you know from the equation, mu is equal U is equal to J divided by rho V. So that's how you can do it. So that wraps up our lecture 8 until I will upload your attendance assignment with this one. So you check in the ULearn with this, that there will be an assignment separated from the lecture. So I wish you good luck, and assalamu alaikum warahmatullah. Thanks for your patience. See you in the next lecture.